Hey guys, it's Felipe, DevRel here at Flow Foundation, and today I'm going to be teaching you how to use an MCP server, what it is, why it's important, and also we're going to delve a bit into AI agents, how they're constructed, and why they are very interesting right now. So first, let's get into MCP servers. I think this is going to be the best way to get into everything. So initially, the reason why we care about MCP servers is because LLMs by themselves, they can't really do much, right? They're very good prediction models, and basically what happens is that they have an input, and then there's a lot of regressions within this model, and it outputs the most likely answer, right? So, for example, if you were to say, I don't know, Lisan al, you know, the AI, the LM will be likely to infer that the last word that's remaining is Gaib, right? So obviously the Dune reference. But these models are trained on historical data, and they're very limited as a model itself because you can just prompt it and get a response. But for the stuff that we care about, for real world applications, they're very limited. We envision this world where we have a Jarvis type assistant, where it's, hey Jarvis, send money to this person. Hey Jarvis, start my car. And the way we can achieve this is by making the LLM models interact with the real world. So in this initial stage, we just have the LM by itself. And the LM by itself is all right, but the issue is that it is still very limited on what it can do. It's basically just a prediction model. And the reason why we care about MCP is because it creates standards, and I'll explain a bit more on what this means. So yeah, the LLMs by themselves, they can't really do much. They can't do tasks. They just provide a response based on training data, and basically they just predict the next step. So yeah, this is a very limited stage. So then the next stage after that was when we started connecting LLMs with specific tools. So basically what would happen is that you could have a tool, for example, this would be an API, so that it can interact with like certain clients out there. It could be a RAG model even. You can tell it to post a Twitter, on X. But it's still very limited, and the reason why this is annoying is because every time you want to connect your LLM to something in the real world, you'll have to make this connection. You'll basically have to create this whole framework for connecting it. Now, this is where MCP servers become very interesting, specifically because as developers, we really give importance to standards. The world operates based on standards. And by standards, I mean that we have a unified way in order to be able to interact with our systems. So it's basically very cumbersome to be in this stage too, right? It's very, very cumbersome because you need to build every tool, and you don't have that level of assistance that we envision with Jarvis, with Iron Man. But yeah, the issue is that the service provides each service provides like tools differently. The issue is that each service provides tools differently. So we would have to build each and every single pipeline, basically, in order for our agents to interact with the world. And this is way too cumbersome. So why do we care about MCP servers? Because specifically it sets up the guidelines or the rules for how we are supposed to interact with our services. So what do I mean by this? There's a very good example where imagine that you are ordering some food at a restaurant, right? Here in stage two, basically what's happening is that let's say you are the LLM, right? And then the tool specifically is going to be, let's say, a chef. And this pipeline is, and usually we use REST API pipelines. They are standards, but you would have to communicate it to the waiter, and then the waiter will communicate it to the chef, and then the chef will bring out the order to the waiter, and then the waiter will bring it back to you. But that only works if you know exactly what you want and it's very specific. But sometimes you don't have that amount of certainty. So that's where MCP servers are pretty cool, because in this analogy, what would happen is that you just simply state what you want, not not in a specific sense where you want a specific dish, but you can just state what your cravings are. And then the model will basically communicate this to the chef so that the chef knows exactly what would fit to your cravings. And then they would bring you back that. So that's where it becomes very interesting. It creates a unified layer that just makes sense to LMs. We provide a simplified and easy access way in order to bring information to LMs in a way that makes sense to them. So it's very easy to connect LMs with these MCP servers, and the LM will have access to outside resources, which is the part that is interesting. Specifically, there are 3 things that the MCP servers can do. The first one is using tools. So specifically, these guys I've put out here. So for example, a tool that can be utilized is sending money or creating a transaction on the blockchain. So basically what would happen is that you would tell your agent, you try to orchestrate money saying, I want to send a transaction to this address, and it'll be able to do that. But we also have another layer on top of this, which is called resources. So MCP servers can give you access to resources, which is basically docs and files that you can provide to the LM. So if you want to fetch data from some part, that's basically using a resource. And finally, there's prompting. So you can create prompts with what the MCP server can provide. And then now, so we can go just a little bit more in depth. What is happening is that we have this MCP client, right, which is in many cases your IDE, let it be Cursor, Windsurf, whatever. We have Claude Desktop or an actual AI agent itself. And then this MCP client will interact through the protocol, because MCP is the Model Context Protocol, and it will interact with the server. And the server itself will be able to communicate with the service, and then the service will be able to provide information back to the server and vice versa, and then the server will feed that back into the client. So what's interesting here is that this pipeline right here, this way we set up the interaction, it's actually determined by the provider, right? The service provider is gonna determine how they want to be interacted with. So this creates a unified way in order for any agent, any LM to be quickly interacting with these services. So that's where it becomes pretty cool, because you don't have to guess a lot of times, or you don't have to create something out of nowhere. You can just plug and play basically. And as a creator of a service, then you can determine exactly how you want other frameworks to interact with you, how you want other agents to interact with you. So that's where it's pretty interesting, because it unifies the way LMs interact with services. Instead of everybody speaking different languages, we just set up one unified language through which any agent can communicate with this server. But yeah, so to go a little bit more in depth, we can see here the basic flow of how users, LLMs, and the calls they make are actually operating. So for starters, the user is going to be able to interact with the LM and prompt some sort of question or command. So let's say, for example, the user in this case is interested in sending a transaction, right? Or even fetching data from the blockchain. So what will happen is that the LM will be able to quickly interact with the server, and it'll just use standard in and out server transport in order to be able to see all the tools available within the MCP server, right? So when you create an MCP server, there is a schema of all the lists, of all the tools that the MCP can provide. And so the LM has an idea of, okay, I can do this, I can execute this, I can provide this sort of information, and all of that is stated out within the MCP server. So once the LM has an idea of what's going on, then it can be able to actually execute those calls. So, for example, in this case, where the objective of the user is to be able to retrieve some sort of data from the blockchain, what will happen is that the user will prompt the LM saying, what's the balance on this address? And then the LM will be able to read all the tools that the MCP server has. And if it finds that one of the tools is a way for the if it finds that in one of the tools it has the option to retrieve data from the blockchain, then it will execute that call. So they will have a function call that will request the tool call, and then the tool call will be executed with the service, and then they will have a response. So within these schemas, there is a specific manner for how the interactions are supposed to occur, and how there's a specific manner that's also stated on how the answer is supposed to be received. And so what happens is that the tool has a response, which then we get a function result that goes back into the LM. And then once the LM has that result, it can be able to feed that information to the user. It can be able to display that information. So within this flow, basically what's happening is the user prompts the LLM to use this MCP server tool in order for it to read information from the blockchain. So it'll execute that tool call. And then once it provides information from the blockchain, it will be able to provide that information to the user. It will be able to display the balance in a specific account. Okay, so now let's focus on how to build an MCP server. Specifically, we're going to be interested in the Flow MCP server. So for starters, we're going to go here to cursor. And there's two ways you can interact with MCP server. You can be running it locally, or you can be interacting with some sort of standard transport. For the matters of this specific tutorial, I'm going to be focusing on doing everything locally. But yeah, so the first thing that we would need to do is the first thing that we're going to do is we're going to clone this repo right here. So we're going to go git clone and then insert this specific repo. You guys can follow the tutorial on the Flow documentation site, and it will be working as well. Specifically because I'm running everything locally, I'm going to be using Node, but you can use the tutorial. You can just follow the tutorial on the Flow documentation and it will be fine. So once we have this repo, let's go into the Flow MCP folder, and you'll see that we have a couple of stuff here. So for starters, let's just go with npm I to download all the dependencies. All right, cool. And then we'll be able to go npm run build. And there we go. So what happened? Specifically, we installed all the dependencies that our MCP server is going to need. And if you guys go to the upper right button up here, we can see the cursor settings. And in the cursor settings, we can see MCP tools. And we can add a specific custom MCP. So this is where it becomes pretty nice, where we can just, plug and play, add some stuff, and it's very quick. So for example, if we were to follow this specific tutorial, we would just use this. We would just use this JSON file, and then that would be our way to connect it. But since I'm going to be running everything locally, I need to modify this a bit. So instead of npx, it's just going to be node. And then instead of having this whole thing over here, we're going to go specifically to where the MCP server is. And in our case, it's this specific folder. So, oh, this is wrong. Flow MCP, Flow MCP. So we're interested in this specific file. This is where the actual agent is initialized. So once we have this, right, we can go to our cursor settings, and then we can see that the Flow MCP here is now appearing within the tools. The reason why it doesn't appear as if it's enabled is because we need to restart cursor. Whenever you change the source code for cursor, we need to we need to restart it so it can clean itself up. But yeah. Oh, found an error. Yep, there we go. So as you guys can see here, now we have all the tools available. It's still red because it's still disabled. We need to restart cursor in order for it to be enabled, but you guys understand that these are the tools that we have at our disposal. So let's quickly do this. Let's quickly restart cursor. All right. And now let's go to MCP tools. And then now you can see that all these tools are enabled, which is great. So out of the tools that are here, you can see, we can get the flow balance, the get token balances, the get a contract if you want to bring the whole cadence contract. We can, swap, we can get quotes. We can do a lot of stuff that's already occurring on chain. We can get a lot of this data on chain. But yeah. All right, so now let's try it out. For example, let me just pull up an address. Okay, perfect. So right now I'm in my wallet, and in specifically my testnet wallet, and as you can see here, I have 100,000 flow tokens. These are obviously testnet tokens, so they're not worth anything. But I want to check my balance for this specific account. So let me just copy the address, and then I can ask, what is the flow testnet balance of the following account? Perfect. Now it's planning its move. Great, now you can see it's trying to call this MCP tool, and which one? The get flow balance. So there is an option in cursor, I think it's called YOLO mode, or I think they changed it, the name, but it used to be called YOLO mode. And what would happen is that it could, the cursor, the agent, the coding agent could just basically run all the tools that you gave it access to. I think that's a bit risky, so I always ask it for it to check with me before it tries to run any tool. But yeah, so we're gonna run this tool, and it's calling the MCP tool. Okay, and it received, perfect. It received the response back, and then you can see the account has 100,000 testnet tokens. So the Flow MCP server is working perfectly. This is great. All right, so now let's hide this. And we'll go a bit through what's actually in this folder. So if you go down to the SRC folder and then tools, here you can see all the tools that are going to be listed. Okay, all the tools. And also, if we go here to index, we can see also all the tools that are being listed. So why do we care about this? Because this is what needs to be specified. In case you want to create a new tool, you want to contribute to the Flow MCP. Basically, what you would do is go here to tools and then create a new tool. For example, let's just call it let's just call it test tool, right? And then in test tool, we would need to create an index.ts file. We would need to create a schema.ts file. And then if you want to do some additional testing, you can basically do test tool.test.ts. And then you would have your testing file just to make sure everything's working. But yeah, so I'll just go through one of these. It's actually go through the get balance. So it's probably here in flow balance, and then we can see here. Yeah, it's get flow balance, perfect. So specifically, we can see how this works. What we care about is this right here. This is how the LLM is being trained with what the tool does. We have a specific name for the tool, which is get flow balance. And if we go back here, get flow balance, this is specifically the tool that was called. And then we have a description of the tool. This is going to inform the LLM of what this tool does. So the LLM will be able to recognize, okay, I have all these tools to my disposal, and each and every single one does this and does this and does this. That's where this is really important. And then, as we can see here, in the handler, this is telling the argument specific that needs to be passed for the tool to be executed. For example, in this part right here, what it needs is the arguments. So as we can see here in the arguments, what it needs to pass is an address, which is a string, right, which we provided, and it also needs a network, which we had also stated that was the testnet. So if we go here to the prompt, the question that was asked is, what is the flow testnet balance for the following account? So here we're specifying, okay, the account is the 0x5df, and the specific network is the testnet. So those are the arguments that are being passed. The LM can understand this, and it will be able to pass these arguments. And then the result that it will receive is specifically this. It will receive a type of text. And the text will be the specific amount, which is this. The 100K flow tokens. That's the answer. So this is what's actually occurring. Let me close this. This is what's actually occurring. We specify within our tools how we want to receive information, how we're going to give it, what the tool does, and what's the name of the tool. So the LM can know exactly what to call, how to call it, and how to receive the information. But yeah, and then it has some error handling. Okay, cool. Now let's go to the schema. And the schema is just specifically stating what needs to be passed. So we have the address and the network, right? So the flow address to check for, which is something we provided, and also the network, right? Which it can be by default mainnet, but we can also use testnet. But yeah, and then you can do some testing on these tools just to make sure that everything's working. Please contribute to the Flow MCP. There's still a couple of stuff that needs to be added to the Flow MCP. So any sort of contribution will be greatly rewarded. But yeah, so then once we have this, I'm just gonna close test tool. So let's imagine that we create the test tool and then we would need to import it here. So we would import, let's say, get test tool, right? Whatever. And basically, what we're doing here is importing it and being able to place it also here, so that once the MCP server is initiated, all the information of all the tools available will be there, and then we'll be able to go here to this folder, and then this is where everything else will exist. So once the MCP server is initialized, that's where you'll be able to find all the information here. Another important file to mention here is the server.ts file within the main src folder. So why is this important? Because this is what initializes the server. Specifically, we're using FastMPC because it's just a very quick way to initialize a server, and you don't need to build something out of scratch. You can already use the existing frameworks that work very well. But yeah, so basically here is what's happening when you create the initialize the server and you're registering every single tool. You have the tool name, description, the parameters it's supposed to receive, and you're waiting in order to get the arguments. You're waiting to get the results. But yeah, that's basically it. So as you guys can see, this is why MCP is super important, because it's a unified way in order to interact with anything. So that's why most of these companies that are working on trying to bring AI agents into their ecosystem, they're building MCP servers because they want LLMs to be able to quickly interact with their services. So this is why MCP is super exciting, because it is getting us closer to that Jarvis level sort of assistant. because Jarvis needs to have access to each and every single aspect of your life in order for it to be able to optimize for it. But yeah, so this is pretty cool. Also, it's worth mentioning that this mcp.json file is actually in your you can see here, it's in your cursor, and then you can also go to your, let's say, your Cloud desktop folder, and then you can also insert an mcp.json file there. Something also pretty cool is that it's very plug and play. Let me try to show you this. So for example, if we go to cursor MCP, yeah, so you can basically, connect MCPs to cursor incredibly quickly. So let's go here. We can install MCP cursor. So let's say you want to connect it to your GitHub, right? So let's open cursor. Okay, I'm not gonna put my personal access token, but you get the idea. I can just install it and then be able to connect it, and that's it. And then your agent will be able to access your GitHub, and it will be able to read the important information from GitHub. But it's not just GitHub, and you saw how easy that was. You have all these different MCP servers that you can connect. Let's say you want to go with Figma. You want to be able to create some pretty beautiful front ends and kind of like iterate on ideas for visual stuff. You can also do that here. So I'm not gonna really care too much about this, but basically you can connect very quickly the tools that you want. It's very plug and play. So me as a user who wants to enhance the capabilities of my agents and the LLMs that I'm using, MCP is super useful for this. It's very plug and play, which is great. But yeah, all right. And actually, just to show something, let's close cursor and then open it back up, and you can see it's loading the tools. This one's loading tools, and it's still going to be loading because we didn't provide any information. GitHub, it doesn't have it enabled because we didn't provide a personal access token. But you can see that the Flow MCP was not enabled previously because we changed the mcp.json, and we just clicked in these in this site in order to add it to cursor. That's all we did. But what's happening is if we go to our mcp.json file, look, all these MCP servers got added automatically, which is great. But yeah, we can disable them as we choose. But yeah, that's basically it. So let me just clean this up real quick, so I don't care about that. And then actually, because I edited the mcp.json file, you see now it's all clean here. It only has a Flow MCP connected, and in order for it to work, we once again need to restart cursor. All right, and let's actually do that. Cool. All right, let's go back. Cool. Alrighty. Now we're gonna go into and talk a bit about let's close this guy. AI agents, which is pretty cool. All right. So, why are agents interesting? Okay. So agents are interesting because they remove a lot of the abstraction that users have to deal with in the real world, right? So let's say I don't know a single thing about finance, right? But the only thing I know is that I want to buy a silly meme coin with a dog, right? But I don't know anything about blockchain. I don't know anything about pump.fun or whatever. But the only thing I know is that I want to buy a silly dog coin. So what I can do is I can talk to an agent, right, like a chat bot, that I can give it my information, such as my address, and my private key, although not very recommended, and tell it to prompt some sort of actions and tell it do this, do that. And also AI agents are pretty good because you can give them personalities as well. You can help the whole user experience overall, just by having some sort of agent that's more personalized to your needs or to a specific persona. But yeah, so what we're going to do is build an AI agent, a very quick one. So there's different frameworks for AI agents, specifically for the tutorial on the documentation here on the Flow site. We're using LangChain for the agent. But there are different types of agents. So LangChain is a pretty nice one if it's just plug and play with different frameworks that you want to interact with. But there's also Eliza, like this one. And the cool thing about Eliza is that it has a very powerful personality of an agent. Like you can specify how you want the agent to interact. And I'll just explain in a very, very general and broad sense how agents work. So this is the agent, right? There's an agent that is operating on an LM. So what does the LM ingest? How does it become an actual AI agent? Well, it's always connected to a specific database from which it has information that is part of its core memory. And I'll explain that why there's a difference between just memory and the database. And there's a character config file. So in this character config file, you can specify how you want the agent to behave, how you want it to communicate. If you want it to be very bold and somewhat rude, or if you want it to be very eloquent and dapt, or if you want it to be very eloquent, or you want it to be somewhat shy. All of these things you can determine it within the character config, which is pretty cool because it does help cater to very specific niches within the market, right? So let's say you're creating a game where you want an NPC, for example, to have a certain personality. Well, the cool thing is that you can create an AI agent for that NPC, and that NPC will have a different, an evolving dialogue with the user based on what's happening within the game, but it'll have a predetermined personality. So it's not like each and every single thing that the agent is saying is something already pre-made, but it will have a sort of pre-made personality that it must follow. So it's pretty cool. And yeah, then this LM, what it does is that it's always trying to have some stuff that's in its core memory and in its database. So what the things are in its database are things that do not change, right? That's something that the agent must always have when it's processing the information. And then memory is something that is somewhat transient, where it's relevant now, or it was somewhat relevant, but the further back it goes, the less meaningful it is for the context of the agent. And yeah, so we also have evaluators, which are basically functions where the agent does an action and then the agent thinks on the action it just did. So let me see, if I did something, was that a good thing? Did it fulfill what I wanted it to fulfill? And it's always evaluating. The reason why it's important for it to evaluate is because it can provide better answers and it reduces hallucinations. And then the agent has actions, right? So these actions are pretty straightforward. It's just a way for the agent to execute something that the user wants. And there's also providers, which are basically things that give agents information. And then there's these different types of clients that are basically plugins, and you can basically connect your agent to a Twitter client so that the agent is posting things on Twitter with a certain personality, right? It can connect with a CoinGecko client so it can pull information from CoinGecko. You can do a couple of pretty cool stuff. But in a very broad sense, this is how AI agents work, right? They have a specific context that you have specified, and that can be evolving based on the information you provided. And it basically processes this information to give the most expected output that this model would provide. So yeah, now let's go on to the Quicksart for the agent kit. So the first thing we're going to do is go to our designated repo, run this command, and then we're just going to call it on-chain agent for now, lang chain, and then we're going to go with the EVM, and then we're going to go with a custom chain ID, right? Because we're interested within the Flow ecosystem. So we can choose the Flow mainnet or Flow testnet for the purposes of this tutorial. We're going to go with the Flow testnet, which the chain ID is 545. And then our RPC URL, which is also provided within documentation. And it's this one right here for the testnet. All right. And cool, perfect. So now once we got this, let's go into the folder. And then we can go npm install. Oh. Perfect. Okay, once we're done putting in the OpenAI API key as well as the private key and the information in relevant information within the .env, we're gonna need to fix a couple of stuff. So for starters, this can use faucet. We need to make sure it has the Flow testnet, and then we're also gonna go into the Flow documentation and copy this Flow context message. This is what is going to allow us to basically provide the agent with some sort of information that they can use. For example, these are some key facts about Flow. Specifically, the RPC URL is going to be super important for the agent. And then also for when we create the agent on the front end, when we create the chatbot, we want to make sure that the agent has access to the Flow docs, so it can be able to quickly understand certain things within the Flow ecosystem. But yeah, once we have that, we can go with npm run dev. Then once we have our local host going on, we can actually start interacting with our agent. So how about we go with what's the price of Flow? Then it'll think. It'll keep on thinking. Perfect. And now we will get the current price of Flow, which is 35 cents. So yeah, that's basically how you create an agent, and that's pretty much it. So we've seen how MCP works, and now we've seen how agents work, and that's where it's really special when you get to combine them both. So you increase the capabilities of your agents, but also keeping the incredibly smooth UX that agents provide. But yeah, if you guys have any other questions, please let me know. And all this information can be found within the developer docs on Flow. And yeah, I hope you guys were able to learn something pretty cool.